SkyTran is a personal rapid transit system first proposed by inventor Douglas Malewicki in 1990, and under development by Unimodal Inc. Lightweight two-passenger vehicles suspended from elevated passive magnetic levitation tracks are expected to achieve the equivalent of over 200 miles per US gallon fuel economy at 100 miles per hour or faster. A prototype of the SkyTran vehicle and a section of track have been constructed. Inductrack, the proposed magnetic levitation system for SkyTran, has been tested by General Atomics with a full-scale model. Unimodal Inc. is now collaborating with NASA to test and develop SkyTran. The first public experiment is being built in Tel Aviv, with planned completion by the end of 2015. A SkyTran system is being built in Israel as a pilot project. Additional projects have been proposed and/or are planned for cities in France, Germany, India, Indonesia, Malaysia, Pakistan, Saudi Arabia, Slovenia, the United Kingdom, and the United States. System details: to minimize maintenance and make switching on and off the tracks efficient at high speeds, early versions of the system proposed using the Inductrack passive magnetic levitation system instead of wheels. Passive maglev requires no external power to levitate vehicles. Rather, the magnetic repulsion is produced by the movement of the vehicle over shorted wire coils in the track. The cars would be driven by a linear motor in the track or vehicle. Therefore, the system will have very few moving parts. Primarily just the vehicle itself moving along the track, its parking wheels and door, and fans in heating and air conditioning units. So its promoters refer to the system as solid state. The passive maglev coils are enclosed and supported by a light shell called a guideway that also captures the vehicles mechanically to prevent derailment. Malewicki proposes a 3D grid design that avoids accident-prone intersections by grade separation, with guideways and their exit and entry ramps crossing above or below each other. Tracks will be supported 20 or 30 feet above the ground by standard metal utility poles. They could also be attached to the sides of buildings. After identifying problems with Inductrack and the cost associated with it, SkyTran described an improved design during a Horizon BBC interview with SkyTran at NASA Ames in Mountain View, California. Comparison with other public transit systems: according to the U.S. National Transit Database, the average light rail system costs $5.66 per passenger. Light rail projects have cost $100 million per mile while SkyTran would cost only $10 million per mile. SkyTran infrastructure reduces the weight of empty vehicles to under 70 pounds per foot, compared with light rail vehicles weighing 990 pounds per foot. Maximum capacity of the system is 11,500 passengers per hour per direction is reached by spacing vehicles at 1/2 second spacing. At 80 miles per hour, vehicles would be spaced at 59 feet and stopped by multiple redundant safety systems. By automating control of the system, SkyTran would be made safer than driving by eliminating human error. As lines reach capacity, a new line would be built parallel to the first 0.5 to 1 mile away to provide better coverage of the network. History: Malewicki conceived the basic idea of SkyTran in 1990, filing a U.S. patent application that year that was granted as U.S. Patent Number 5,108,052 in 1992. He published several technical papers on SkyTran in the following years. In 1991, he presented a paper entitled People Pods, Miniature Magnetic Levitation Vehicles for Personal Non-Stop Transportation to the Society of Automotive Engineers Future Transportation Conference in Portland, Oregon. The paper is a thorough description of the concept at that point, although some important features of the current SkyTran design are only discussed as options, including magnetic levitation rather than wheels and hanging below the guideway instead of riding above it. The paper describes how Malewicki had built and driven a freeway-legal 154 mpg car in 1981, but realized it could never be safe on a street surrounded by far larger and heavier vehicles. Elevated tracks would allow a very light vehicle to be safe. They are also basic to the system's inexpensiveness, because there is no need to acquire a huge right-of-way and tear down buildings. It presents an aerodynamic analysis supporting claims of very high energy efficiency. It also described how a very light vehicle that can squeeze both surfaces of a track simultaneously could reliably achieve a 6G deceleration, allowing it to brake safely to a stop from 100 miles per hour in just 55 feet. In 1999, Malewicki was invited to present an overview of the future of transportation for the Institute of Electrical and Electronic Engineers proceedings. His submission, rather than projecting the future, described a retrospective of solid-state transportation systems imagining the progress of the SkyTran invention from the perspective of the year 2052. A decade later, he was invited to present an update for their November 2009 issue on linear motor-powered transportation. In the same year, he also gave interviews to the industry magazines Industrial Design and EV World. Once Malewicki and his partners began making proposals to transit systems, these proposals and their other efforts to publicize the idea began to be described in popular technology magazines and local and national news articles. The 2008 energy shortages stimulated renewed interest in green vehicle proposals such as SkyTran. The cover of Popular Science magazine's June 2008 special issue on the future of the environment featured a SkyTran-like vehicle prominently in its future green megacity. The Maglev SkyTran topic quoted a number of SkyTran and personal rapid transit ideas, such as passengers exiting and boarding at offline elevated portal stops while high-speed traffic continues to speed by on its main line. In September 2009, the U.S. NASA signed a Space Act Joint Development Agreement with Unimodal. Unimodal has tested prototype vehicles on short guideway sections at NASA's Ames Research Center, in Mountain View, California. NASA control and vehicle dynamics simulation software was made available to Unimodal, which hired NASA subcontractors to program them using US DOT grant funding. In June 2014, Unimodal and Israel Aerospace Industries contracted to build a 400 to 500 meter elevated loop test track on IAI's campus in central Israel. If the pilot problem is successful, IAI will build a commercial SkyTran network in the city of Tel Aviv. See also. References. External links: SkyTran official site, U.S. Patent D329028, monorail vehicle, filed June 12, 1990 and issued September 1, 1992. Archive of old SkyTran.net site, Are magnetically levitating skypods the future of travel? The International Maglev Board, SkyTran Vehicle and Guideway at NASA Ames, NASA SkyTran press release.